In this lesson, we're going to begin our study of the rational zero theorem. Now, in this course, this is the first time that we've talked about, or we're going to introduce the rational zero theorem. So let's look at the rational zero theorem. So the rational zero theorem says this. If you have a polynomial function, and so remember in general, this is what a polynomial function looks like. And all these coefficients, a sub n minus 1, a sub 2, a sub 1, and your constant coefficient, a sub 0, if all of those are integer coefficients, then the rational zero theorem says this. Every rational zero for this function, if it has any, okay, if it has any, every rational zero will be of this form. P divided by Q, all right, where P is an integer factor of the constant coefficient. So whatever your constant is, remember your constant coefficient is the one that doesn't have a variable with it. So whatever your constant is, P would be an integer factor of this number. Q is an integer factor of the leading coefficient. So if remember the leading coefficient, the leading term is the term with the largest exponent. Doesn't mean it's the first term that you see listed. Recall that. It's the one with the largest exponent. So a sub n, we're going to let that be a sub n, the leading coefficient. So Q would be an integer factor of the leading coefficient. Now, one other thing I need to remind you, or I need to tell you, is that when you list your rational zeros, your possible rational zeros, P divided by Q, they must be in lowest terms. Okay, so lowest terms, which means that the only factors that P and Q have in common is the number 1. Okay? All right. Now, let's look at this. Okay, so let's remind ourselves what factors of 8 are. So the factors of 8. So remember, a factor of 8 would be 1. So the factors of 8 are 1, right? Because 1 times 8 is 8. So 8 is also a factor, right? 2 is a factor of 8. So remember factors. So since 8 is a factor of 8, that means that if I divide 8 by 8, I get a remainder 0. 2 is a factor of 8, right? Because 2 goes into 8 evenly. So remember, 2 times 4 is 8, right? So 4 is a factor of 8. But keep in mind, though, that it's not just these positive integers. And by the way, so these are the only positive integers that are factors of 8. But also the negatives. Negative 1, negative 8, negative 2, negative 4. So I could rewrite this and say this. The factors of 8 are plus or minus 1, plus or minus 2. Let's put it in order. Plus or minus 4, plus or minus 8, right? So 8 has 8 factors. 4 positive, 4 negative. All right, so let's look at this one. All right, so let's talk about the factors of 12. All right, so 1 is a factor of every number. So by that notion, then I can say plus or minus 1, right? Now 1 times 12 is 12, so plus or minus 12. The next factor of 8, if we go in order, would be 2. I'm sorry, I didn't mean 8, I meant 12, would be 2. And don't forget, 2 times 6 is 12, right? So then I can say plus or minus 2, plus or minus 6, couldn't I? Can you think of another factor of 12? 3. 3 times 4, very good. So I can say plus or minus 3, plus or minus 4. And then that's about it, right? So these are the only factors of 12. Plus or minus 1, plus or minus 12, plus or minus 2, plus or minus 6, plus or minus 3, plus or minus 4. Now that you remembered what factors are, now let's go back to our rational zero theorem. Okay, so the rational zero theorem says this, that if you have a polynomial function, and if this polynomial function has any rational zeros, it may not have any, right? You saw in a previous example, let me get to that previous example. You saw, let me remind you real quick, that in a previous lesson, that this polynomial function didn't have any rational zeros. They were both irrational. You saw in another example that this polynomial function did not have any rational zeros. In this case, they were both complex zeros. So I just want to keep in mind that the rational zero theorem says this: if you have any rational zeros, if a polynomial function has any rational zeros, then the rational zeros will be of this form: p divided by q, where p is an integer factor of the constant coefficient, the constant term, and q is an integer factor of the leading coefficient. And also keep in mind that p goes in the numerator, q is in the denominator. Okay? And also, we're going to talk about this again, p divided by q, that rational zero, that possible rational zero must be in lowest terms. All right? Okay, so we're going to start with a very simple example. Now, in example one, we're going to kind of do two parts. So in part A, what I want you to do is to list the possible rational zeros. So list the possible rational zeros. Sometimes they'll use the word potential. Now remember the theorem, our rational zeros theorem, so the rational zeros theorem, I keep going back to it because the more times you look at it, and we discuss it, the easier it is to understand it. So the rational zero theorem must be of the form p divided by q, where p is an integer factor of the constant coefficient and q is an integer factor of the leading coefficient. Okay? So, and also it's very important, I remind you that when listening to factors, and don't forget about the plus or minus. So it's not just positive integers, look at the negative counterparts as well. Okay? That's going to be important. Okay, so here's what you do. So if the question says list the possible rational zeros, then you're going to say the possible rational zeros are, okay, now remember it's p divided by q, right? So remember in the numerator, those are going to be factors of your constant term. So in this case, it's negative 12. Factors of negative 12 divided by factors of the leading coefficient, which is 1. All right, so that's what I would write first. Now let's talk about the factors of negative 12. So the factors of negative 12, plus or minus 1, comma, what else? And let's go ahead and write it in order. Don't forget the 12. 1 times 12 is 12. But also plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, right? So those are the factors of negative 12. Whether it's positive 12 or negative 12, it's still the same. So if this was a positive 12, you would still list the same thing that we have here. Okay? And the only two factors of positive 1 are plus or minus 1. That's it. Okay, now here's what we need to do now. Okay, so remember in our discussion on the rational zero theorem, remember p divided by q must be in lowest terms. Okay, which means that the only common factors that p and q have in common is the number 1. So we're gonna apply that here. Okay, so this is an easier one because see there's only plus or minus 1 in the denominator. You don't see any other factors of 1 down here. All right, so what you're going to do is this, and we're going to see this in another example as well. you're going to take each of these plus and minus factors that you see listed, and you can divide it by, and in this case, there's only one plus or minus. So you're going to say that's going to be plus or minus 1 divided by plus or minus 1. Just bear with me for right now. Plus or minus 2 divided by plus or minus 1. Plus or minus 3 divided by plus or minus 1. Plus or minus 4 divided by plus or minus 1. Plus or minus 6 divided by plus or minus 1. Plus or minus 12 divided by plus or minus 1. All right, you may say, well, how do you simplify each of these? There's a plus or minus and there's a plus or minus. Okay, let's kind of review something before we go further. I want to show you something. Do y'all agree that if I have plus 6 divided by negative 1, that's a negative 6, right? If I have a negative 6 divided by negative 1, that's a positive 6, correct? If I have a positive 6 divided by positive 1, that's a positive 6. If I have a negative 6 divided by positive 1, that's a negative 6. I'll agree? So what I want you to see is this. Plus or minus, let me do it this way. Plus or minus 6, look at this one right here. Plus or minus 6 divided by plus or negative 1 gives you negative 6, right? Same thing here, doesn't it? Plus or minus 6 divided by plus or minus 1 gives you a positive 6. So you see how these two are the same? So if those two are the same, then that means they must both be equal to plus or minus 6. So here's the point I'm trying to make. Plus or minus 6 divided by plus or minus 1 will give you plus or minus 6. So what some students, and I'm hoping that this helped to understand why plus or minus divided by plus or minus is still plus or minus. So if you have a positive 6 divided by negative 1, or negative 6 divided by positive 1, you get negative 6 in both cases. If you have a negative 6 divided by negative 1 and a positive 6 divided by positive 1, you get positive 6 in both cases. But if you look at it, the numerator, positive, negative 6, the denominator, positive, negative 1, you get negative 6. In this case here, positive, negative 6 divided by positive, negative 1, you get positive 6. So positive, negative 6 divided by positive, negative 1 is a positive, negative 6. So just remember that a plus or minus divided by a plus or minus is going to be a plus or minus. All right? Okay. Now, let's go back to this. So a plus or minus divided by plus or minus is plus or minus, right? And 1 divided by 1, reduce it, that's just 1. So I need you to say this is just plus or minus 1. 2 divided by 1 is 2, so plus or minus 2. 3 divided by 1 is 3, plus or minus 3. 4 divided by 1 is 4, plus or minus 4. 6 divided by 1 is plus or minus 6. 12 divided by 1 is 12, so you get plus or minus 12. So notice these are your possible rational zeros. So that's the answer to part A. So your possible rational zeros are those. Now remember the theorem from the previous lesson. Remember the theorem from the previous lesson we talked about the real zeros. Remember, a real number is either rational or irrational. So the theorem says that for a polynomial function of degree n, you have at most n real zeros. Okay? And a real zero is either rational or irrational. So according to what we just said, then this function has at most 2 real zeros. They could be rational, they could be irrational, but it has at most 2. If any of them are rational, if any if any of these zeros are rational, it will have to be one of these that are listed. And you can have at most 2. Okay? You may not have any, but you have at most 2. Okay. Now, this is easy enough, guys. This is easy enough to where we can actually find them. So part B, find the zeros. And so remember, to find the zeros, you set the function equals 0. So to find the zeros, we're going to say x squared plus x minus 12 equals 0. And then this is easy to factor, so I'm not going to use a quadratic formula. I'm going to go ahead and factor this. So I get x plus 4, x minus 3 equals 0. And so if I set each of those factors equal to 0, I get x plus 4 equals 0, x minus 3 equals 0, and I get x to be negative 4, x to be 3. Those are your zeros. And they're both rational. And notice, negative 4 is listed, isn't it? And positive 3 is listed. See that? So these are my 2 rational zeros. So the rational zero theorem only says this. If you have any rational zeros, it will be of the form P divided by Q, where P are factors of the constant coefficient and Q are factors of the leading coefficient. Notice that in this particular example, there were 2, 4, 6, 8, 10, 12, plus or minus 2, plus or minus another 2, plus or minus another 2. So there were 12 possible rational zeros. So according to the theorem, rational zero theorem, if you have any rational zeros, it will be one of these. In this case, there were 2 of them, and they were both listed. Okay? The other thing I want to remind you is this. Do you see that so remember P in the numerator was the factors of negative 12? So when I factor this, when I factor this, do you see that 4 and negative 3 are factors of negative 12? And down here, the factors of 1 is just plus or minus 1, right? So you see the coefficients here, 1x times 1x is 1x squared, right? So that rational zero theorem has a relationship with the factoring that you did earlier. All right, let's look at example 2. All right, so example 2 says this. So suppose that f of x is this quadratic function, and you want to list the possible rational zeros for f of x. All right, so remember the possible rational zeros, and as we go on, see the degree is 2, right? So according to a theorem we learned in a previous lesson, you can have at most 2 real zeros. And the rational zero theorem says that if you have any rational zeros, then it'll be one of these that we're about to list. So the possible rational zeros are, okay, so remember P divided by Q. So remember P are integer factors of your constant coefficient. So 6. So the integer factors of 6. And the denominator would be the integer factors of the leading coefficient. So the integer factors of 2. All right, so just go ahead and list the factors of 6. Don't forget the plus or minus. So plus or minus 1, plus or minus 2, right? Because 2 times 3 is 6, 1 times 6 is 6. Plus or minus 3, plus or minus 6. Y'all agree that's all of them, right? 1 goes into 6 evenly, 2 goes into 6 evenly, 3 goes into 6 evenly, 6 goes into 6 evenly. For the denominator, the integer factors of 2 are plus or minus 1, plus or minus 2, and that's it. All right, now remember what we did in the previous example. Remember what we did? So we took each of these, we divided by, in this case, it was only one pair. Notice though, in this case, there are two pairs, plus and minus 1, plus and minus 2. So the way I would approach this is this. I would go and take each of these divided by each of these. All right, so this would be plus and minus 1 divided by plus and minus 1. Plus and minus 2 divided by plus and minus 1. Just do it like that. Plus and minus 3 divided by plus and minus 1. Plus and minus 6 divided by plus and minus 1. Then, so we took care of the plus and minus 1, right? Now we're going to do the plus and minus 2. Plus and minus 1 divided by plus and minus 2. You do it all over again. Plus and minus 2 divided by plus and minus 2. Plus and minus 3 divided by plus and minus 2. Plus and minus 6 divided by plus and minus 2. Okay? Now, remember, that's not the answer, because remember, it must be in lowest terms. Lowest terms. Okay. Now, so here's going to be your answer. So the possible rational zeros are, so if this quadratic function has any rational zeros, so the possible rational zeros, so if it has any rational zeros, it will be one of those. 1 divided by 1 is 1, so plus or minus 1 divided by plus or minus 1 is plus or minus 1. 2 divided by 1 is 2, so plus or minus 2 divided by plus or minus 1 is plus or minus 2. 3 divided by 1 is 3, so plus or minus 3 divided by plus or minus 1 is plus or minus 3. 6 divided by 1 is 6, so plus or minus 6 divided by plus or minus 1 is plus or minus 6. 1 divided by 2 is a half, so plus or minus 1 divided by plus or minus 2 is plus or minus 1 half. See how it looks? 2 divided by 2 is 1. I already have it listed, right? So don't list it again. So that's why it says make sure it's in lowest terms. So this and this are the same thing. Okay, keep that in mind. 3 divided by 2 is 3 halves. I don't have it listed, so plus or minus 3 halves. Be careful here again. 6 divided by 2 is 3. I already have it listed, right? So that's it. So those are your possible rational zeros. And so if this function has any rational zeros, it will be one of these. Now, in the next lesson or the lesson after that as well, we're gonna learn how to determine if this has any, how to determine without factoring. In fact, we're going to use synthetic division. Using synthetic division, we're going to determine if any of these are actually rational zeros, how to determine this using synthetic division. All right, so those are your possible rational zeros. But what I want to do though is actually remind you how to solve this quadratic equation. So let's find the zeros. Find the zeros. So to find the zeros, remember you set this equal to 0. So we have 2x squared minus 7x plus 6 equals 0. And I made this example, I made this problem to where it actually factors and you actually get rational zeros. So let's go ahead and factor this. And so when I factor this, I'm going to get, let's see, 2x, x, for 6, let's use 3 and 2. And let's see, I'm just trying to make sure it works out. So let's put 2 here, 3 here. The last sign's positive, so these have to be the same. They're both negative. And let's verify. 2x times x is 2x squared. A negative 3 times a negative 2 is a positive 6. The outer's negative 4x. The inner's a negative 3x. I get 7x, negative 7x. Okay, so then I set each one equal to 0 using a zero factor property. And I want you to notice something. So when I solve for x, I get x to be 3 halves. When I solve for x here, well, I already solved for x. So x is 2, right? I should have said this first. I should have said x minus 2 equals 0, so x is 2. So those are your zeros. And in fact, they're rational, aren't they? Rational zeros. If they're rational zeros, they better be one of these listed. Isn't 3 halves listed? Yep, right here. Is a positive 2 listed? Yep, right here. Okay? So that's using the rational zero theorem. Now, what I did here, though, was I just factored. to actually find the zeros. But they're not always going to be that easy. So the next lesson you're going to learn if there are any, you're going to learn how to use synthetic division to determine what the zeros are. Okay, so let's look at example 3. So example 3. Okay, so all we're going to do here is just list. We're just going to list the possible rational zeros. We're going to learn in the next section how to actually find any rational zeros if there are any. So we're just going to list the possible rational zeros. So remember how to do that. So the possible rational zeros. So remember it's P divided by Q, where P are going to be integer factors of the of the constant coefficient, in this case -6, and the denominator Q would be the factors of the leading coefficient 1. So the factors of 1. And so the factors of -6, plus or minus 1, plus or minus 2, right? Because 2 goes into 6 evenly. And don't forget, 2 times 3 is 6, so you better put plus or minus 3. And then 1 times 6 is 6, and that's it. That's all the factors of -6. The denominator, the only factors of 1 are plus or minus 1. All right, and so you're going to remember how to do this. You're going to say plus or minus 1 divided by plus or minus 1, plus or minus 2 divided by plus or minus 1, and so on. So you're going to say plus or minus 1 divided by plus or minus 1, plus or minus 2 divided by plus or minus 1, plus or minus 3 divided by plus or minus 1, plus or minus 6 divided by plus or minus 1. And guys, you could skip this step because almost all of you will be able to visually see that plus or minus 1 divided by plus or minus 1 is just plus or minus 1. All of you will see 2 divided by 1 is 2, so plus or minus 2. 3 divided by 1 is 3, plus or minus 3. 6 divided by 1 is 6, so plus or minus 6. All right, so you could have skipped this. Okay? And so there's your answer right here. That's what I need to see. This is what I need to see. I don't want to see you saying this is your answer. I want to see this because that's simplified. That's in lowest terms. Okay. Number 4. Number 4, let's suppose that f of x is this. So let's say f of x is 4x to the 5th plus 12x to the 4th minus x plus 3. All right, so again, you want to list the possible rational zeros. Now remember, as we went through the process, did you use any of these other terms? No. So the rational zeros only applies when finding the rational zeros. You only used the leading coefficient and the constant coefficient, right? And it kind of makes sense. It kind of makes sense because if we go back to this example here, that very simple example where we found an example 2. So if you look at the rational zero here, 3 and 2. So 3 is a factor of the constant term, and 2 is a factor of the leading coefficient, right? Over here, 2 divided by 1, 2 is a factor of 6. 2 divided by 1, 1 is a factor of 2. Do you see where they come from? 2 times 1 is 2. Negative 3 times a negative 2 is a positive 6. So that's why we only use the leading coefficient and the constant term, because when we do this using very simple quadratic equations, we can actually see where those rational zeros are coming from. They're coming from the factors of the leading coefficient and the factors of the constant term. So the point being that all you need to find the possible rational zeros are your leading term and your constant coefficient. That is all you need. You need a sub n and you need a sub 0. Okay? A sub n and a sub 0. Okay, so factors, so the possible rational zeros are, all right, so the factors of 3 divided by the factors of 4, right? So the only factors of 3 are plus or minus 1, plus or minus 3. For 4, there's plus or minus 1, plus or minus 2, plus or minus 4. Y'all agree? That's it. And so remember what we did. You're going to take each of these divided by each of these. That's the best way to do it. So do this first, then this. So this becomes plus or minus 1 divided by plus or minus 1. Plus or minus 1 divided by plus or minus 2. Plus or minus 1 divided by plus or minus 4. So that takes care of plus or minus 1. And let's do plus or minus 3. Plus or minus 3 divided by plus or minus 1. Plus or minus 3 divided by plus or minus 2. Plus or minus 3 divided by plus or minus 4. Now let's reduce. Okay, so our answer, so the answer, 1 divided by 1 is 1, right? So that's going to be plus or minus 1. 1 divided by 2 is a half, so plus or minus 1 divided by plus or minus 2 is plus or minus 1 half. 1 divided by 4 is 1 fourth, so it'll be plus or minus 1 fourth. 3 divided by 1 is 3, so plus or minus 3. 3 divided by 2 is 3 halves, so plus or minus 3 halves. And then 3 divided by 4 is 3 fourths, so plus or minus 3 fourths. And that's it. So those are your possible rational zeros. So this function, if this function has any rational zeros, okay, it will be one of these listed. All right, and now it doesn't say anything about irrational zeros. It just says that, remember, this is called the rational zero theorem, not the irrational zero theorem, the rational zero theorem. So these are all rational numbers. Y'all see that? None of them are irrational. They're all rational. So these are your possible rational zeros. Okay, let's look at example 5. All right, so the possible rational zeros, all I want to do is just find the possible rational zeros. I want to find them. That's going to be in another lesson. I just want to list the possible rational zeros. So remember, to find the possible rational zeros, you just need to know a sub n, and you need to know a sub 0. So your constant term and your leading coefficient. Doesn't matter what these others are, right? We saw that. We just need to list the factors of your leading coefficient and the factors of your constant term. So the possible rational zeros. So this function has any. If it has any, it may not have any. But if it does, it will be one of those that we're about to list. Possible rational zeros. Okay, so the numerator is the factors of, now always make sure you put the right one in the numerator. Factors of -8, your constant term. The denominator would be your factors of your leading coefficient, which is 2. Okay, so here we go. The factors of 8 are plus or minus 1, plus or minus 2, plus or minus 4, right? And plus or minus 8. Y'all agree that's the only ones, right? Those are the only integers that goes into -8 evenly. 2 times 4 is 8, 1 times 8 is 8. And the only factors of 2 would be plus or minus 1, plus or minus 2. All right, so let's go ahead and list them. So we're going to take each of these divided by each of these. So plus or minus 1 divided by plus or minus 1. Plus or minus 1 divided by plus or minus 2. Then let's go to the next one. Plus or minus 2 divided by each of these. So plus or minus 2 divided by plus or minus 1. Plus or minus 2 divided by plus or minus 2. And let's go to the next one. Plus or minus 4 divided by plus or minus 1. Plus or minus 4 divided by plus or minus 2. And let's do the next one. Plus or minus 8 divided by plus or minus 1. Plus or minus 8 divided by plus or minus 2. Now remember, that's not the answer, right? Because you don't want to say plus or minus divided by plus or minus. You want to make sure you reduce each of these. And some of those repeat. So your answer will be this. And by the way, you can go from here to the answer. So I know that almost all of you can go from here without having to list this to the answer. But if you need to, list it. It helps some of you. So listen, but that's not the answer. This is the answer. 1 divided by 1 is 1, so plus or minus 1. 1 divided by 2 is a half, plus or minus 1 half. 2 divided by 2 is, 2 divided by 1 is 2, so plus or minus 2. 2 divided by 2 is 1, we already have it listed. 4 divided by 1 is 4, plus or minus 4. 4 divided by 2 is 2, I already have it listed. 8 divided by 1 is 8, plus or minus 8. 8 divided by 2 is 4, I already have it listed, so there's your answer. So if this function has any rational zeros, it will be listed in this group right here. Okay? Number 6. Suppose that my function is this. We have 3x to the 5th minus 7x squared plus 4x plus 2. Okay? So your possible rational zeros will be the factors of your constant term, which is 2, divided by the factors of the leading coefficient, which is 3. So those will be plus or minus 1, plus or minus 2. Over here, plus or minus 1, plus or minus 3, right? And then, so let's go ahead and rewrite this then. Plus or minus 1 divided by each of these, plus or minus 2 divided by each of these. Plus or minus 1 divided by plus or minus 1. Plus or minus 1 divided by plus or minus 3. Let's do the next one. Plus or minus 2 divided by plus or minus 1. Plus or minus 2 divided by plus or minus 3. And then our answer. Again, you could have skipped this and just gone to the answer. So the answer then would be 1 divided by 1 is 1, so you must say plus or minus 1. That's not the answer, right? This is the answer. 1 divided by 3 is a third, so plus or minus 1/3. 2 divided by 1 is 2, plus or minus 2, and then 2/3. All right, that was number 6. Okay, let's look at this one. This will be the, let's see, let's do this one. So number 7. So let's look at number 7. All right, number 7, let's suppose in number 7, we have this. We have f of x is 9x to the 4th minus 3x cubed plus x squared minus 8x minus 4. So remember, to find the possible rational zeros, I just need to know the leading coefficient and the constant coefficient. That's all I need. I don't care what any of this other stuff is to find the possible rational zeros. So the possible rational zeros will equal the factors of, make sure you put the correct one in the numerator, it's a constant term, -4, divided by the factors of 9, the leading coefficient. So the factors of -4 are plus or minus 1, plus or minus 2, plus or minus 4. The factors of 9 are plus or minus 1, plus or minus 3, plus or minus 9, right? 1 times 9 is 9, 3 times 3 is 9. 1 times 4 is 4, 2 times 2 is 4. And that's it. So those are the only factors of -4. Those are the only factors of 9. Now let's go ahead and rewrite this. Each of these divided by each of these. So plus or minus 1 divided by plus or minus 1. Plus or minus 1 divided by plus or minus 3. Plus or minus 1 divided by plus or minus 9. Now the next one, 2. Plus or minus 2 divided by plus or minus 1. Plus or minus 2 divided by plus or minus 3. Plus or minus 2 divided by plus or minus 9. Let's do the 4 now. Plus or minus 4 divided by plus or minus 1. Plus or minus 4 divided by plus or minus 3. Plus or minus 4 divided by plus or minus 9. Okay, so 1 divided by 1, 1 divided by 3, 1 divided by 9. That's what you see here. 2 divided by 1, 2 divided by 3, 2 divided by 9. That's what you see here. 4 divided by 1, 4 divided by 3, 4 divided by 9. That's what you see here. So now the answer will be, 1 divided by 1 is 1, so plus or minus 1. 1 divided by 3 is 3, plus or minus 1/3. I'm sorry, 1 divided by 3 is a third. 1 divided by 9 is 1/9, plus or minus 1/9. 2 divided by 1 is 2, plus or minus 2. 2 divided by 2 is 2/3, plus or minus 2/3. 2 divided by 9 is 2/9, so plus or minus 2/9. I'm not going to have enough room, so I'm going to list it here. 4 divided by 1 is 4. I don't have it listed, so we're going to list it. Plus or minus 4, then plus or minus 4/3, and then plus or minus 4/9. Okay? So that's your answer. So remember, we have at most 4 real zeros. Some of those may be rational, some of those may be irrational. But if they're any rational, it will be one of these listed. Okay? I can have at most 4 though. Okay, let's do one more and I think we'll be done. All right, so this will be number 8. Number 8. Suppose our function is this, number 8. Suppose we have, let me go ahead and quickly find where it is. Okay, here it is. So let's suppose we had 6x cubed minus 17x squared plus x plus 10. So if I'm going to list the possible rational zeros, I need to know the leading coefficient and I need to know my constant term. And so the possible rational zeros will equal the factors of 10 divided by the factors of 6. And so the factors of 10, I'm going to go ahead and list it down here. The factors of 10 are plus or minus 1, plus or minus 2, right? And then 2 times 5 is 10, so plus or minus 5. And then 1 times 10 is 10, so plus or minus 10. That's all the factors of 10. Y'all agree? The factors of 6, plus or minus 1, plus or minus 2. 2 times 3 is 6. And then plus or minus 6 is 1 times 6 is 6. All right, so then we're going to list each of these by each of these. So that's going to be quite a few things we're going to list now. So there's going to be quite a bit here. So plus or minus 1 divided by plus or minus 1. Plus or minus 1 divided by plus or minus 2. Plus or minus 1 divided by plus or minus 3. Plus or minus 1 divided by plus or minus 6. Now the next one, 2. Plus or minus 2 divided by plus or minus 1. Plus or minus 2 divided by plus or minus 2. Plus or minus 2 divided by plus or minus 3. And then plus or minus 2 divided by plus or minus 6. Okay, so that takes care of the 2. Now let's do the 5. I'm going to list it right here. Plus or minus 5 divided by plus or minus 1. Plus or minus 5 divided by plus or minus 2. So 5 divided by each of these, right? That's what I'm doing. Plus or minus 5 divided by plus or minus 3. Plus or minus 5 divided by plus or minus 6. Now let's do the 10. Plus or minus 10 divided by plus or minus 1. Plus or minus 10 divided by plus or minus 2. Plus or minus 10 divided by plus or minus 3. And then finally plus or minus 10 divided by plus or minus 6. Okay? Now that's not the answer because you got to simplify this. You got to reduce this. So the answer then will be this. 1 divided by 1 is 1, so we're going to say plus or minus 1. 1 divided by 2 is a half, so plus or minus 1 half. 1 divided by 3 is a third, plus or minus 1 third. 1 divided by 6 is a sixth, plus or minus 1 sixth. 2 divided by 1 is 2. I don't have it listed, so I'm going to list it. 2 divided by 1 is 1. I already have it listed, right? See, it's already here. 2 divided by 3 is 2/3, plus or minus 2/3. 2 divided by 6 reduces 1/3. Okay, 1/3. I already have it listed, right? So don't list it again. But remember, reduce lowest terms. Let's go to the next one. 5 divided by 1 is 5. I don't have it listed, so I must list it. 5 divided by 2, I don't have it listed. 5 divided by 3, I don't have it listed. 5 divided by 6, I don't have it listed. 10 divided by 1, I don't have it listed. So 10 divided by 1 is 10. 10 divided by 2 is 5. I have it listed right here, right? Okay. 10 divided by 3, I don't have it listed. 10 divided by 6, remember reduce lowest terms. 10 divided by 6 is 5/3. I have it listed. So that's it. So there's your answer. That's what you give me. Don't give me anything else. It must be plus or minus each of these. All right? Okay, so that will take care of the rational zero theorem. And all I want to do in this lesson was to be able to list the possible rational zeros for each of the function that we listed, for each of the function we talked about. So that'll be the end of this lesson. In the next lesson, we're actually going to talk about, or maybe the lesson after that, where we actually find which of those, if there are any, which of those are rational zeros, and we're going to use synthetic division. So that'll be the end of this lesson.